Hi, I'm going to discuss what the E module is and its relationship to the PQR modules. They're, they're all tetrahedra and they're based on the golden cuboid. And for our purposes, this golden cuboid will have as this edge here the equivalent of 1 or a unit. And so this edge here will be 0.618 or 5 to the negative 1, and this one will be 0.381 or 5 to the negative 2. So the three dimensions of the golden cuboid are in phi. The T or the E module, the T and the E both have the same form, and that will be discussed in another video. But there's a module, a tetrahedron, that Buckminster Fuller called the E module, and it's 1/120th of a rhombic tricontahedron. And it's this form here. There is a left and a right-handed unit. I'm just showing you one of them. And there's 4 in this golden cuboid. And then there's also a center tetrahedron which has just 4 of the same face. That tetrahedron is called the U module, dubbed by a guy named Tal Anderson. It's actually twice the volume of the E module that resides within this, 4 E modules that reside within this cuboid, and the U module is actually twice the volume of those. Okay, just a quick I also want to say that there's a left and a right-handed unit, in that they're the same volume and then the same shape, but one of them is left and one is right-handed, and they work together in concert, so to speak, to fill all space scaled by phi, something that I discovered. And scaling by phi is an interesting concept in itself, but let's just first show the left and right-handedness of this shape. So there's the right-hand unit, let's say, or which one you want to call the left or the right. Anyway, it doesn't really matter. They're complementary to each other. They're both required. And I'll show you that it's 1/20th of a rhombic tricontahedron. I think I'll just kind of highlight the surface. Oh, it doesn't want to do that because of that one there. Okay, there's the surface. Now if I hit that, you can see that that's the rhombic tricontahedron, just some of the edges are denoted. That has a 30 faces of a, I guess you can call them golden rhombus. It's derived from the golden cuboid. Okay, now what we're really after is the PQR modules. Well, once again we have the golden cuboid, but now we have strung a body diagonal through the center. And it's interesting in that on the other form we had red and yellow edges. And that's because if you look really closely, I should kind of get this so it's easier to work with, at the center, excuse me, at the hub, sorry. If you look really closely at the hub and the way that the blue rectilinear edges are oriented, you can see that there's rectangular openings, and that their orientation to one another then creates the hypotenuse in red, whereas the other golden cuboid, it's made the same, but the orientation of the 3 struts is shifted 90 degrees or spun 90 degrees, and therefore these don't exist in Zoom Tool or Reality Zoom Tool or Reality Zoom, but they do in the virtual Zoom, the V-Zone that I'm using, which is nice because these won't actually, they don't exist. They won't fit into the holes. But depending on how you make the golden cuboid, you can make the version with the red and the yellows, or if you make it with the orientation at 90 degrees, then you can build this center body diagonal. Now, if you recall, I said that this edge here would be 1. Did I say that? Well, no, I didn't. But in this case, I want to say this is 1. Or what I really need to say is that this edge here, or body diagonal, is exactly twice the length of this edge here. Okay. So in the golden cuboid with the PQR modules, there is 3 different tetrahedra. They all 3 have the same volume as the E module. So one is P, one is Q, and one is R. And I call them peculiar E modules. So I'm just kind of highlighting some faces. This face on the surface has the same face as of the regular E module. These ones on the rectangular face, the surfaces. But as you can see, they're kind of joining differently because they don't have that inner scaling triangle. They have 4 right triangles, whereas the original E module has just 3 right triangles and a scaling triangle. But the main triangles we're interested in are that the let's say these interior triangles where these 2, and then there's the third one. It's funny how I can't seem to see it, but it's right here. Okay, this triangle I just highlighted here, this is actually 1/2 of an equilateral triangle. So that allows us to build rational face-angled 5-fold symmetric polyhedra. And that's kind of the beauty of these PQR modules. As you saw, the E module makes the rhombic tricontahedron, which is an irrational surface face angles. So anyway, that's an equilateral triangle here. And then the other 2 triangles are parts of essentially the pentagon and the pentagram. I call this piece here 1/2 of a star point, which is here. I should just highlight the face. As you can see, this is a star point. And then this other one, it's like the other Penrose tile, so to speak. It's got 54 and 36 degree angles instead of the 18 and 72 of that right triangle, and they complement each other, and they fill in the sides of the star point in the pentagon. Okay, so that is what I wanted to show, but then most of the modules are grouped in 4s to make almost all the structures, and that's kind of has its own value. So for instance, I'm going to take this unit here, and I'm going to project its I'm going to screw this up, I think. Alright, I think I will. I don't want to. So